So example 3 and 4 of areas of triangles. We'll make these a little bit more involved, a little bit harder, but still applying the same principles. So number 3, I want you to find the area of the following triangle. Okay, so write out your questions, draw your triangle. So your triangle I'm going to give you this time, it's going to have an obtuse angle in it. It's going to look like this. Go to the ruler. Yeah, we're going to have A, B, C. I'm going to give you 103 degrees here, 14.3 centimeters on this side, and 9.5 centimeters on this side. So it's going to be tricky to get a perpendicular height in this question. So this is going to involve our new form. Remember our new formula for the area of a triangle up at the top in here in green. So the area of a triangle is a half AB sine C. Just to remind me of what I need. So remember, I need two lengths and then the angle between them. So when I look at this question, I'm asked for the area. That's the first thing I'm thinking of. And I'm thinking, I have two lengths, which is good. I have this length here, and I have this length here, but I don't have the angle between them. So if I can find that angle, I'm in the money. I can definitely find the area if I find that. Or I could try and think about maybe finding this length, because I'd have two lengths and the angle between them. So there are a couple of ways of kind of thinking about this question. But what I would also be thinking is that because I've got an angle and its opposite side, because I can't calculate the area directly, because I've got this, if we remember from the earlier videos, whenever this situation happens, sine rule is quite often the way forward. So sometimes you just want to use what you've got. Don't worry too much about, I've got to find the area. Yes, you do need to find the area, but let's see what we can find with what we've got. So let's label our triangle up. So opposite big A, we want little a. Opposite big B, we want little b. And opposite big C, we want little c. So we can get it all labelled up. Okay, and because I've got A and capital A, and I've got little c, that means I can actually find the value of this angle in here. So if we call this y, then we can find the angle, and then you might be able to see the way forward from there. But let's find the angle to start with. So I'm going to use sine rule. So I know that A, in fact, I'm trying to find an angle. So I'm going to write sine rule as sine capital A over A equals sine capital C over C. In fact, we can just leave this unknown here as capital C if you want to find it in here. So it corresponds to the angle. Sub in, so sine of the angle at A, which is 103, over A, which is 14.3, is sine C, which we don't have, that's what we're going to find, over little c, which is 9.5. So sine capital C times both sides by 9.5, 9.5 sine 103 all over 14.3. And to calculate capital C, the angle, we can inverse sine both sides of this equation. So let's work out 9.5 sine 103 divided by 14.3, so 0.647, inverse sine that, and you get 40.33, etc., etc. And again, I don't need this angle to work out my area directly, so I'm not going to round it. It's not my final answer. So that's the angle at C. Therefore, we can find the angle at B. Because if we've got the angle at C, the angle at B will be 180 minus the other two. Just use an angle sum of a triangle. So minus 103 plus this 40.3 recurring. So we can actually find B. You can leave that number saved in your calc. You can save it as a letter if you want on your calculator, or just leave it up as the answer, and then you can do 180 minus, and then in brackets 103 plus ants, and you should get 36.66, etc., etc. Okay, so once we've got the angle at C, we can put that in there. That then enables us to find the angle at B, which is 36.66. And now, I now have the correct setup for my area. I have two lengths, and I do now have the angle between them. So if it goes back to the start of the video, that's what I kind of wanted, that's what I was looking for. So now I can use my area, my new area formula. So therefore, the area of the triangle, we know the formula is a half AB sine C, it's at the top, but in this question, we've actually got A as a length and C as a length. So here it will be a half AC, and I've got B as the angle, that 36.66 is B, so sine B. So again, two lengths, angle between them, sub in a half A, which is 14.3, C, which is 9.5, squeeze this on, sine of 36, oh, sorry, in fact I can move along slightly. Remember, use the exact value. So because I've got that value up in my calculator, I should probably still have it up in my display from here. I can just take sine of that, so sine ants 0.59ish, and then I can multiply by my half, multiply by my 14.3, and multiply by my 9.5. Give me 40.55, etc. Which is 40.6 centimeters squared. It's an area, and then our degree of accuracy, 3SF. So we can't always find the area directly, as we did in the first two examples, which were very straightforward, just plug into the formula. Sometimes you'll be given other bits of information, but use what you've got to work out whatever you can. So here we worked out angle C first. That then enabled us to find angle B, and then we can use our two lengths and the angle between them to find the area. This time I've already drawn the question out for you. So this is question 4, so I've written out the question, so copy it down, draw out your triangle. You want to pause the video here, just so you've got time to catch up with all the details, and then play it when you're ready for the answer. Okay, so this time we're given the area of the triangle. But again, if they mention the area of the triangle, it's probably going to involve one of the two formulas that we've got for area of a triangle. And as soon as I see this question, I see two lengths and the angle between them. It highlights that a half AB sine C, our new formula, is going to be the way forward. So here, the area is a half AB sine C. And you can write area of triangle if you want. So area of the triangle is a half AB sine C. Remember, we can interchange these letters, so let's label our triangle, let's see what we've got. So opposite capital A, we want little a. Opposite capital B, little b. And opposite capital C, we want little c. Should be well in the habit of labeling it up to start with. So here I've got A and C, and I've got the angle at B. Well, I haven't got the angle at B, I've got the area, but I'm going to be using a half AC, because I've got those two lengths, sine B, because that's my own. But this time, I've got the area. So I can put this in on this side of the equation, because I've kind of got the answer here already. So I'm going to sub in, so 3.7 is the area, that's going to go in on this side for the area. A half A, which is 2.9, C, which is 3.2, they're all labelled on the diagram, sine of the angle at B, and the angle at B is x. And now I've got an equation to solve with one unknown in, i.e. x, so I want to get the sine x by itself, and then I can solve this. I don't like the fraction at the start of this, on this side, the half, but if I times up by the denominator, if I times both sides by 2 to get 7.4, it's going to cancel the bottom of this, so I'll just be left, the half will disappear, because I'll just be left with the 1 on the top, and 1 times anything is just anything. Then I can either multiply the two decimals and divide, I can divide by both at the same time, it's up to you. So sine x will be 7.4 divided by both of these things. And then if I inverse sine both sides, I get straight to my answer. I'm not writing all these 4 steps in because I feel like we should be comfortable with what we're doing now. So 7.4 divided by these two things times together. 185 over 232. Shift sign, so inverse sine, 52.88, etc. So x, or the angle at B, the unknown, is 52.9 degrees. It's an angle, so we'll go 1 decimal place.